So some additional practice problems with the quadratic formula. So we're going to find the solution or solutions to the following quadratics using the quadratic formula. We're going to simplify any of those irrational solutions to the simplest radical form. So as we work through these examples, we're going to use the same process that we've been using. We want to make sure everything is simplified, that it is rearranged in standard form, and that it's set equal to 0, and then we're going to check for a discriminant. So here we have A is 5, B, there is no middle value here. The B value, remember, is my coefficient in front of the variable. It's not here, so we give it a value of 0, and then the -3 is my constant value, so that's going to be my C value here. So when I plug this into the discriminant, I have 0 squared minus 4 times 5 times -3. And when I simplify that, I get 60. Any number greater than 0 tells me that I'm going to have 2 solutions. So I know I'm going to be looking for 2 solutions. So I'm going to plug this into my quadratic formula. So here I have negative b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. And so when I simplify this, remember that I had, I've already done this radicand, the expression underneath the radical. I worked it out here as my discriminant, and I got 60. So I have the square root of 60 divided by 2 times 5, which is 10. And in all reality, that 0 also goes away, and I'm just left with plus or minus the square root of 60. So what I have here is x is equal to the square root of 60 divided by 10, and x is equal to the negative square root of 60 divided by 10, because remember, this plus or minus symbol means that I have 2 different solutions here. So now I need to figure out how to simplify that square root of 60. So I'm going to start looking for some factors. I know there's 1 in 60, there's 2 in 30, there's 3 in 20, and then there's 4 in 15. And 4 in 15 already involves a square, so I'm going to use 4 in 15 here. So the square root of 60, I have the square root of 4 times 15. So that gives me, I can take out that 4, square root of that is 2 times the square root of 15. And I do need to check if 15 if I have any other factors there. But the factors of 15 are 3 and 5, and neither of those are squares, so it won't help me to go any further than this. So 2 times the square root of 15 is about as far as I can go. So I'm going to rewrite my answers here, and I'm going to write them as 2 times the square root of 15 divided by 10. And I'm going to just keep the plus minus sign out front because it keeps me from having to write them as 2 separate answers when the only difference is that positive or that minus sign. So I can keep that plus minus sign out there and keep it written as just one solution, even though I know that it can be broken apart into 2 solutions. It just keeps it a little simpler, but it could be written either way. Now, notice that the 2 and the 10 are do have a greatest common factor we could pull out. They have a factor there. They're both divisible by 2, so I could divide the 2 by 2 and the 10 by 2, and that would leave me with a plus or minus 1 times the square root of 15 divided by 5. So my answers could be written, I could have x is equal to the square root of 15 divided by 5, and I could have x is equal to negative square root of 15 divided by 5. And both of those are viable solutions for this quadratic. I'm just going to write my simplest form as plus or minus the square root of 15 divided by 5. And that's going to be my final answer for this problem. All right, let's take a look at number 2. So on number 2, we have, again, it's in its simplest form, but there is a greatest common factor. So I'm going to go ahead and take that out just to make my life a little bit easier. It kind of simplifies things a little bit better later on. So I'm going to take that 2 out. I'm going to divide everything by the 2. Okay, and when I take that 2 out, I'm going to use these values for my A, B, and C. So A is going to be 2, B is going to be -5, and C is going to be -2. And so I'm going to plug that in to find my discriminant. So I have negative 5 squared minus 4 times 2 times negative 2. When I plug that into my calculator and simplify that, I get 41. And 41 tells me that there are, again, 2 solutions. It's just any number larger than 0 here. So I'm going to plug these values into my quadratic formula. So x is going to be equal to negative b, which in this case is negative 5, plus or minus the square root of b squared, negative 5 squared, minus 4 times a times c, divided by 2 times a. So when I simplify this, I have a 5 plus or minus the square root of, and all of this simplified was 41 divided by 4. So I start looking for factors of 41. So I can check using my calculator, and it looks like 41 is a prime number. So since 41 is a prime number, I don't have any factors I could take out, and definitely not any squares. 5 and 4 don't have anything that I could simplify with. So my final answer here is 5 plus the square root of 41 divided by 4. And x equals 5 minus the square root of 41 divided by 4. But rather than writing them separately, I can just kind of combine that, make it a little bit easier. And I can write my final answer as 5 plus or minus the square root of 41 divided by 4 as my final answer. And that's in its simplest form. So just like before on the notes, we talked about that you don't have to simplify it if there's no square to pull out of that radicand. All right, so number 3, let's look at this one. So this one also in simplest form, there's no greatest common factor. Let's go ahead and do our discriminant. So A is 6, B is 9, and C is 5. We plug these values in. We have 9 squared minus 4 times 6 times 5. And we end up with the number negative 39. And anytime we have a number that's less than 0, according to our discriminant, that tells us there are no solutions. And if we worked it out and we went ahead and put these values into our quadratic formula, say you forgot to do the discriminant, so you plugged it into your formula anyway, you would have a negative 9 plus or minus the square root of 9 squared minus 4 times 6 times 5 divided by 2 times 6. And so what would happen here is you would end up with negative 9 plus or minus the square root of negative 39 divided by 12. And this is where the problem lies for us. That square root of a negative 39 gives us a number that is not real. And so that is the reason why we're going to call this a no solution quadratic. All right, and the last question here that we have is number 4. Again, already in standard form, already simplified. There are no greatest common factors here. So let's go ahead and do our discriminant. So A is 11, B is negative 8, and C is negative 1. So we're going to plug this in. Negative 8 squared minus 4 times 11 times negative 1. We simplify that, we get 108. Any number greater than 0 means that we have 2 solutions here. So we're going to plug this into our quadratic formula. So x is equal to negative b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. And we're going to simplify that. So we end up with 8 plus or minus the square root of 108 divided by 22. So we can break that apart, or we can keep it in this simple form. I'm just going to keep it in this simple form. I just wanted you to see in these previous examples that plus or minus means that it is 2 separate equations, and we've split them apart in the past. But for this down here, I'm just going to keep it all in one. And I'm going to look for how to simplify 108. So looking for some factors of 108, if I start looking through those, let's see what I can find. So let's see. It looks like I have a factor, 4 is a factor, so 4 times 27. So I can take that 4 out. Square root of 4 is 2. I get 2 times the square root of 27. And then factors of 27 are 9 and 3. So I have 2 times the square root of 9 times 3 here. And 9 is a square. So if I take that out, I have 2 that was already here times the square root of 9, which is 3, times the square root of the 3 that was left over. So again, the 2 was already here that we just pulled out earlier. We took the square root of 9, which is 3, and pulled that out. And then there was a leftover 3 here that stays under the radical symbol. And so we can simplify that. 2 times 3 becomes 6 times the square root of 3. Okay, so this, I'm going to replace that square root of 108 with 6 times the square root of 3. And if I'm unsure if I did it correctly, please check. Plug this into your calculator and plug this into your calculator, and they should be equal. And if I do that real fast, I would get the square root of 108, and I get 6 times the square root of 3, and both of them equal the same thing. All right, and then don't forget your 22 here on the bottom. All right, and then you notice that 8, 6, and 22 are all divisible by 2. So again, let's go ahead and simplify this. That can become 4, that could become 3, and that could become 11. And I would have 4 plus or minus 3 times the square root of 3 divided by 11. And that's going to be my final answer for this. I can't simplify that any further, so I'm going to do 4 plus or minus 3 times the square root of 3 divided by 11. And so that gives me 2 different answers. I could write it as 4 plus 3 times the square root of 3 divided by 11, or I could write it as 4 minus 3 times the square root of 3 divided by 11. But those are just some extra practice problems with that irrational solutions.